Hello, just give us 2 to 3 minutes and we will get started. Thank you. For those of you who have joined us, we'll go ahead and get started. Welcome to the FlowTech and Rescale webinar. We're going to show a couple of different ways in which you can accelerate your SHIPFLOw simulations by leveraging Rescale's scalable HPC resources. First, I'm going to do some quick introductions. I'm Sarah Dietz. I'm the Business Development Manager here at Rescale. We'll also be hearing from Hiraku Nakamura, one of our application engineers, as well as from FlowTech, Leif Broberg, the Managing Director, and Magnus Osberg, the Product Manager. We're about to get started. A couple housekeeping items. We'll be recording and distributing this webinar later today. And if you have any questions during the webinar, please make sure to ask them in the questions section at the GoToWebinar panel, and we'll answer these at the end. Here's our agenda for today. I'll do a quick overview of Rescale's platform. Hiraku will then demo how users can use the Rescale web interface to set up and run SHIPFLOw simulations. We'll then be passing this over to Leif, who will be giving an overview of SHIPFLOw. Finally, Magnus will present and demonstrate how users can execute simulations from their local GUI using Rescale hardware. We'll finish with some time for questions, hopefully. So Rescale provides a comprehensive cloud platform for running simulations. This platform allows engineers and scientists to set up and execute different types of simulations using a straightforward, easy-to-use interface. Rescale partners with multiple infrastructure providers with over 30 data centers globally, allowing our users to leverage a wide range of different types of hardware, including InfiniBand and GPUs. Users can not only run these simulations, they can monitor their progress in real time, and our administration portal allows IT and management to manage and monitor usage and set additional controls. The platform can also integrate with existing on-premise resources, so IT and management can have transparency and control over resources being utilized through one unified environment. At Rescale, security is our top priority. We go to great lengths to ensure that the platform is secure and that our users' information is secure at every stage. We go through lengthy and in-depth processes to meet strict security compliance and regulation requirements. Users' data is encrypted both in transit and at rest, and when simulations are running, they're run on isolated, encrypted clusters. We're happy to talk further offline in more detail about the different security measures we have in place. Finally, the partnership we have with FlowTech. We have a strong strategic relationship with FlowTech. This partnership enables SHIPFLow users to both purchase on-demand SHIPFLow licensing directly through the platform, as well as allows existing SHIPFLow customers with licenses who need additional compute power to run those licenses on the Rescale platform. As mentioned, Rescale's platform is available globally, and in addition to this worldwide range of data centers, we have dedicated regional platforms in both Europe and Japan for users that require that their data stay within one region. Finally, to segue into our next presenters, there are multiple ways in which users can run SHIPFLow simulations on Rescale's platform. First, Hiraku will demonstrate how users can run using the web interface, and then Magnus later will demonstrate how users can kick off jobs directly from their local SHIPFLow GUI. I'll now be passing this over to Hiraku.
I'll be demoing. First, you can log into the platform from our webpage, and you just click login, and it'll take you to the first page where you will see all the jobs and statuses. And you can see that I've already kicked off one job. And to set up a new job, you just go to the top left corner and click a new job. The typical flow is that you upload a file, select the software you want to use, and then you just select the hardware type, and you just either submit or save it and run it for later use. For the sake of this demo, I'll be showing cloning, which is a feature where you can copy previous input setups and then run a new one, and show you how you would do this. You can either upload a file, which in this case, all sorts of upload or download on the platform is encrypted, or you can select already uploaded files, which are also encrypted, and run analysis. In this case, we already have two input files that are already set up. And to run on Rescale, there is one particular setting that you need to remove. One is this host file, and this file is already accounted for when the job kicks off. So you can remove this. And you need to also change the number of cores that you will be running to match the selection for the hardware. In this case, I'll be using 8 cores. And you can just save the changes. And here you would just select the software. And in this case, it'll be like SHIPFLow. And then you can select the version that you want. And you can always request a version that we don't have. And then your license scheme, either you can purchase on demand or use your own existing license. And then you would enter in your command to run it. In this case, it's just be the input file. And here we already have one set up. And then you would select the hardware. We have various hardwares to match the type of analysis that you want to run. And typically, this will be the list of hardware that you would probably be interested in using initially, but you can always select the ones that match your analysis. And then you can always, change the number of cores, or any number that you need. And this is an optional setting. This is in case there's a runoff of your job and something goes terribly wrong, and this will terminate the job. And on the right, you will be able to see the hardware configuration and also the price for the on-demand and the hardware that you'll be paying. This is really all you need to do. At this point, you can already run the job, or you can save it. And there is one other feature. You can always contact support if there's an issue, or you can share with your colleagues to share results. Let's look at the job that's already been running. And this is a model of a VLCC. We are interested in looking at the dynamic sinkage and the trim. And we can already see that that it's been running, and you can see how the simulation is progressing. And if this happens to be a bad one, you can always stop it. And once the simulation is done, it will save all your files and then encrypt them. And you can take a look at the completed jobs. If you just click the download, it will download all your files, or you can select, for example, using the filter, any sort of ones that you're interested in, and just download those. This is basically the layout of a typical flow. You can also chat with us if you have problems running the job. And I'll hand it over to Sarah.
Thank you, Hiraku. I am now going to pass this over to you, Leif, to present.
Yes, thank you. Okay, can you see my presentation now?
Yes, we can.
I guess some of you who are listening are familiar to SHIPFLOw, but there may also be some of you who are new to the SHIPFLOw system. So in either case, there are different aspects of SHIPFLOw since it's a system consisting of many tools. So I will briefly run through this and try to give you some input on how it can be applied in this concept of cloud environment. For you who don't know, Flowtech is a Swedish company founded in 1989. We are developing the SHIPFLOw software, which is specialized to ships and hydrodynamics. The SHIPFLOw system, as I mentioned, is consisting of several different solvers, and they are of different capacity and are used for different purposes. One set that has, or the oldest one, is a potential flow solver that is used today. A potential flow solver means that it's an inviscid flow, which of course simply implies that the accuracy in some situations will not be very good, but it has some very good features, in particular for predicting and ranking hulls and respect to wave resistance. So these methods are still in use today because they are very fast and easy to use, and they are mostly used, I think, for optimization. Now, nowadays, the most common solvers are RAN solvers, and the program in SHIPFLOw is called XSHUP. It's a finite volume method for incompressible steady flows, and it uses overlapping grids. So these methods are, of course, more accurate than the potential flow methods, but as you know, they require much more computational resources. And the typical applications here will involve self-propulsion simulations, appendages such as energy-saving devices, or free surface applications. But also we still use quite a lot of double model computations in connection to optimizations. We'll talk about that later on. There is also a relatively new solver. It's also a potential flow solver, but this version is time accurate and is used for computing ship in waves. It's, as I said, it's a in-biscuit flow solver, and it takes more time compared to the expand version because it's have to resolve the motion of the ship in time. So as you see, there are several different flow solvers. There are also different types of grid generators. But what I would like to say about this is that it's a very automatic system. So it requires most of the time little involvement from the user, the setups. So it's a very suitable system for parameter studies or optimizations. So that's an important aspect when we look at SHIPFLOw and how to use it in the cloud environment. Of course, for high-performing clouds or clusters, the RANS applications are the most common one. You simply have very large jobs that you want to run faster, utilizing a lot of computer cores. And with SHIPFLOw, that would typically be an energy-saving device application, or it can be viscous free surface applications also with the RAN solver. But when we use SHIPFLOw in the design work, we very often are faced with parameter studies. We cannot be satisfied just with a single computation, but we can require a lot of computations, and therefore the whole work will be time consuming. And here is a very interesting application and the usage of the Rescale platform. So here is one example where, for example, you want to compute resistance at different speeds. You can also have applications for seakeeping where you want to compute response amplitudes at different wavelengths. And then a very interesting application is optimization, and we have started quite recently to work with optimizations of ship sterns, which is possible to do today. And in particular with a platform like Rescale, you can really make these optimizations. Another type of optimization could also be with a forebody to minimize the added resistance. So with this, I would like to let my colleague Magnus Westberg continue and show you some applications and examples how to use the program. Okay.
Okay, thank you, Leif. Hi everyone, this is Magnus Westberg speaking. I will talk about a different way of running SHIPFLOw on Rescale's cluster, and that's running SHIPFLOw like you do on your local workstation or your local laptop and have them launched up on Rescale's HPC cloud. I think this has been touched on before, but I still want to go back to this. The reason why we want to have this. If we look at Rescale, they have very powerful hardware. So if you, for instance, want to do one big computation and run it quickly, you can make use of their cluster. And if you want to do a parameter study or an optimization, you can make use of that. They have many computers, so you can run multiple concurrent runs. On the other side, we have our SHIPFLOw GUI that has to be run on the local computer if you want to use that. And we believe that it's very good for performing parameter studies or optimizations. So because of this, we have developed a new program so that you can run your SHIPFLOw GUI on your local computer and have the computations launched on the Rescale cluster. This is part of the SHIPFLOw installation from SHIPFLOw 6.1.01. All the communications that are being done between the local computer and Rescale's cloud is done via HTTPS, so it's secure communications. In order for you to get a clearer picture on how this works, created this slide. So this is the way you start SHIPFLOw. Usually you start it from the GUI. There is also a possibility to start it from Notepad++ or the command line. For this presentation, I will stick to the GUI way of running SHIPFLOw. So from the GUI, you start the application SHIPFLOw_Rescale. This application will then copy up the input files onto Rescale's cloud. It will create the job and launch the job. And while the job is running, it will monitor the job. And when the job is done, it will copy the results back. So the experience for the user will be like running SHIPFLOw on the local computer. In order to get a clearer picture, I think it's a good thing to do a short demo on how this is done. So I have the SHIPFLOw GUI here, and I want to run a configuration. I will run a really quick example here. So I will use test 2. This is the standard test that you run once you have installed SHIPFLOw, just to test that everything works. So I import this configuration, and compared to the regular test 2, I've added one command, and that's the Rescale command. In here, there are 4 new keywords. In order to be able to access your account at Rescale, you need an API key. This is like your password to your account. So you can get the API key from Rescale, you save it in a text file, and in the API key file keyword, you specify the path to this file. In case the version that you're running doesn't match the version that you want to run in Rescale's cluster, or they might not even have the version that you're running, you can specify which version you want to run on Rescale's cluster. So this is the SHIPFLOw version that you want to run. Then you can specify which node you want to use, and these names in here, they correspond to the names of the nodes in the Rescale web page. And finally, you can select what you want to copy back when the computation is finished, what you want to get back onto your local computer. So you can select to get everything back, or if you just want a text file, an output file with some integrated data, this will be really quick then. Or if you want the output file and the CDNS file, so you can do some more post-processing. For this example, I will use the output file and the CDNS file. Then I'm just going to show you one more thing here. I have the computation, And here in the setup for the computation, we're going to run the script SHIPFLOw_rescale.bat, and this is part of the SHIPFLOW installation. It's in SHIPFLOW bin. So this is the one that should be selected. And since everything is set up, I launched the computation. You can see it's being launched. Here, the local application first copies up the input file, the geometry file, then it creates the job, and it launches the job. You can see here that then after that it starts monitoring the job, seeing how it's going. So it's pending, queuing, starting, and then it's validated. Now it will take a couple of minutes for the Rescale environment to be set up to run SHIPFLOW. So I will stop the demo here for now, and I will continue with a few other things. First, I just want to show one thing. Now I started the job, and these jobs can be seen on the Rescale webpage. So you see the computation I'm running now, it can be seen as a job here. And while this is running, I'm continuing with the presentation. So now I want to show a little bit more advanced way of using the SHIPFLOW GUI and running it on Rescale's cluster. So I will show a parameter study. This parameter study is a tanker KVCC2 running in regular waves. So we will vary the wavelength of the incoming wave, and we'll monitor wave resistance and REOs. As I showed at the demo, compared to regular configuration, you need to have the Rescale command. You need to set the keywords, the API key, the path to that file, the version you want to run, the node you want to use, and what you want to copy back. Then you need to set up the computation so that it runs SHIPFLOW_rescale.bat. When you're going to do a parameter study, you also should set the maximum number of running instances to 0 and needed processors to 0, because you don't want to limit the number of concurrent runs you can run, because you're running on Rescale cluster and not locally. So it doesn't really matter how many processors you have on your local computer. And 0, that means that there is no limit. Then a design variable is created in the SHIPFLOW GUI. We call it wavelength, and we enter it into the configuration. So this is the way we will modify the configuration for this design of experiments that we will do. And of course, we also want to monitor some results. Here we have created 3 parameters to monitor results. We'll monitor the wave resistance and REOs for even pitch. And typical outputs would look something like this if you plot it later on. And then in order to drive all of this, we create the design engine. Here we will use an ensemble investigation that corresponds to design of experiments. So we will have a ready set of a ready series of computations that we want to do. We want to run wavelength of incoming waves with wavelength 0608, 0608, same step size, so 1.0, 1.2, 1.4, and so on up to 2. So there will be 8 different computations. And then we specify which parameters we want to monitor. And here we select the 3 parameters that we created earlier. Then when this is launched, you can see in the monitor that all 8 computations are started at the same time. And these 8 computations will be run on different nodes on Rescale's cluster. So this means that this kind of parameter study will be really quick. And like I did before, if you go to Rescale's webpage, you will now see 8 different jobs. You will see 8 jobs here, each job corresponding to 1 computation. Once a computation is finished, results are copied back to the local computer and then automatically imported into the GUI. And once all the computations are finished, you will have a result table like this in the GUI. And from that, of course, you can easily plot things like the wave resistance. I also quickly want to show a more advanced application. So this is hull shape optimization. And we'll modify the hull shape by 4 delta shift surfaces. So these are patches that you apply on different parts of the hull, and then you change the hull shape in that region. And we will use that in combination with the optimization method. And for this case, it's a genetic algorithm. I will show a few slides on this. So here is one example of one of the patches. So you have the delta surface shift defined here, and you have some control points which you can then change this surface, and you apply that transformation on the hull. So you can change, with a few parameters, you can change the hull shape. This is the bilge radius. The same thing is done for the key line profile of the bossing. So this is a different surface, a different patch applied. Third patch will change the skeg gondola width, and the fourth one will change the section fullness about the skeg. And then the optimization is being run, and this example was run for 5 generations, with each generation consisting of 24 populations. So this means that you can send off 24 computations at the same time onto Rescale's cluster if you do this. And then you wait for results, send off, the next generation will be sent off automatically. So this will be like running 5 computations in series time-wise. So time-wise, it's really efficient to run this on Rescale's cluster. Now, hopefully, the computation that I started earlier should be finished, and it is. So I want to start by showing the task monitor. I can actually show it here. So you see that the computation was sent off and it was run on Rescale's cluster, and everything was copied back. You get table of results the way you always get them when you run them locally, and you also get possibility to post-process the results in the 3D viewer or 3D overviewer. So I'm finished here, and I'm handing back to Sarah.
Thank you, Leif and Magnus, both for those great presentations. Just as a final note here, no matter which way you choose to execute your simulations with SHIPFLOw on Rescale, For enterprise customers, we have this administration portal that adds another layer of security and control. IT and management can monitor usage and set budgets. They can set permissions for software and hardware at a user or group level and set additional permissions and management controls through here. So to close out, we're going to address a couple questions that came in. The first question we received was how a user can access hardware in Europe. They simply need to go to platform.rescale.eu and sign up for an account on our Europe platform. And through that, you will just be using the data centers in our Europe region. This next question I'm actually going to send over to Leif, and it's, do I need to own a SHIPFLOw license locally to run on Rescale's platform?
No, that's not necessary. What it will, I think in practice, maybe it's good to have something local for doing post-processing, pre-processing, etc. But in principle, it's not required. The only thing you have to do is to, via Rescale, get account set up and reorganize, prepare so that the user can run it without any local installation.
Okay, thank you, Leif. And our next question is it possible to run a test or trial of SHIPFLOw on the cloud? And the answer to this is also yes. Many customers want to try this out before committing to moving all of their work to the cloud, and you can contact Rescale or FlowTech directly, and we can get you set up with a trial to allow you to evaluate the platform at no cost and do some testing before you move to production. So that is it for our questions. We want to thank you all for attending this webinar, and again, I want to thank Leif and Magnus for joining this webinar and hosting with us. If you have additional questions, feel free to reach out to us. You can email me directly, sarah@rescale.com, and I can forward your specific questions to the appropriate person. Thank you again. Hope you all have a great day.